How's the interaction with microservices? Well, microservices are said to be DERs, so it's like individually deployable, updatable, replaceable, scalable. If you want to be able to do that, you have all these little applications, all these little components. If you have to manually deploy these components, the chances of making errors, the chances of making failures with the manual process gets way too big. It's already too big when you have one deployment with one big, huge application. But if you have all these little components, and we have like 200 of them, and you have to do this every day, it gets boring, it gets error prone, and it gets not repeatable. So you don't know for sure what's in production, and it's hard to check because we have 200 components. So if you have to check if your deployment is correct, you will have to see if all of the 200 components are working correctly. So that's a lot of work. You can't do this manually. You have to automate things. So I'm going to tell you about the continuous delivery journey. What is continuous delivery? This is a nice definition I found. It's a set of excellent patterns and best practices that can help software teams to deliver software in a reliable and repeatable way. If you read this definition, it doesn't really say so much. It says you have to do it the right way. It's not really that you can be against it or something. I think every CEO thinks, yeah, I want that. I want it reliable, yeah, sounds good. I want it repeatable. So I found that the definition wasn't really enough. You have to zoom into it to really grasp the feeling of what is continuous delivery. So we can zoom into the benefits of it. It reduces time to value. You can deliver more often, and if you automate the whole process, you can do it a couple of times a day. So if you make something, right the next moment it can be in production. That's cool. You have the product owner right next to you who says, yeah, this is okay, this is what I wanted, and then you say, well, now you can use it. That's cool. It improves quality. So if you automate the full process, you are certain about what you are putting into production. If you do it manually, you can make errors. It reduces cost, ultimately. Of course, it first asks for investments because you have to automate all the things. And it gets you data-driven decision making, because to automate the process, you have to have your measurement on your deployment process in place. And that measurement can give you a lot of benefits because you can use it at different stages. And I'll get back to that later in the monitoring part. The next question you can ask, what is continuous? Because continuous would be not even every second, but continuous is, of course, without any break. You can't deliver continuous. I mean, the name is totally wrong. Continuous is like with less interval than we are used to in this definition. It's not really continuous. And if we look at where the enterprises are, well, there are a lot of people who are able to release every 10 days. I think that's the new standard. If you're not out there, you're a little bit behind. Then there are the enterprises striving for more. So there's daily releases, 10 releases a day, 100 releases a day. And this is really the hard part, because that's where you make the transition from being able to do some things manually to having automated the full process. Because you can't deliver 10 times a day without having a full department doing that for you if you don't automate the process. And that's a question I was asked by our CEO. Why would we strive for continuous? Why would we want to have 100 deliveries a day? And that was a good question, because I really didn't have the answer right away. And that doesn't happen to me so often. Mostly I know the answer right away. Because they said, well, as a user, I don't really like change 100 times a day. I'm just using the program, and if it changes once a week, I'm used to changes every half year. So if you are able to change every week, you're making me so happy. And that's enough. You don't have to make me more happy. It's enough to make sure that you can release every week. I'm content with that. And then I thought, well, that's shit, because I really was thinking about going for more, because the fun is, of course, in striving for more often being able to deliver. But after that, luckily, I found the answers. You can do lighter testing, because if you just make a small adaptation and you go to production right away, you are able to say, well, I don't have to do this extensive user interface testing, for example. You can say, well, some of it is mostly for internal application. External, you can be a little bit more prudent about it. But for internal applications, you can say, well, I have a feedback button, and if something doesn't work in our user interface, then just give me the feedback and we'll fix it right away. And if I get feedback, the fix will be there the same day, so we don't have a problem. And user interface testing is expensive, so if you can abort from that, that's a good plan, always. It's expensive not only in making the test, it's also expensive in the time it takes to run the test. So if you can step away from it, do it. You can have fast recovery. If there is an incident, you can just have your recovery in place in just an hour or something, and you can go to production. The damage you have can be much less if you get an attack from outside or something. You can make small changes. Small changes will be less costly. You can test them fast, you can see if the integration is right, and you don't have all these changes at the same time. It's just easier to make small changes. You have no user instruction, because people can adapt to small changes. I mean, applications you use on your web or on your telephone, they change every day, and they don't tell you the new instruction, how to use their app. You just know, because changes are small, you use them every day, and they're intuitive. So we can get to that point if we deploy often. You have motivation of teams. Your team with programmers will be very motivated if you are changing something today and it's in production today. You really get the feeling that you want to finish it at the end of the day, because you know the next day the users will be using it. I think you rather go home when you know the users are going to use it in half a year or something. That's less motivational. You have less dependencies. Smaller changes will make sure that less is changing in the whole landscape. And if you have only a few particles that are changing, it's more easy to assert the risk and to test. And we have quality through full automation best practices. We just do our work better. Deployments were a disaster for a long time. And if you automate it, it's just better. So how did we start? Well, we have this triangle where you say we have culture, which is a set of benefits, beliefs, and traditions. We have practices that are the behaviors and actions that follow from culture. And we have tooling that are instruments that enable us to do our practices. And mostly we start by trying to fix culture. And that's hard. You can't fix culture. You can't say to people, yeah, you have to think differently, because you learned to think that way. So we thought, well, best practice on this triangle is to start with tooling. So you just start with doing things differently, using different instruments. And that changes your behaviors and your actions, and that ultimately changes culture. It sounded really nice when we thought of it. So we started tool-focused, and we gave people a whole bunch of tools. I think it's too extensive to get into this, but a lot of the things will be recognized by you. The result wasn't really what we expected. We had incomplete tests. We had no feature branching, so everything we deployed had to be shipped immediately. We had no measurement, no monitoring or logging in place, and we had no compliance or control. So we gave people like a play garden, and we said, well, just do some nice things with it. And they did a lot of nice things with it. I mean, we really learned a lot. But they didn't do the things that were a little bit less fun, like compliance. Compliance isn't fun. You just have to be obliged to do that. That doesn't come right away. So it wasn't enough to just give them the tools and then say, well, good luck, have fun. You have to do a little bit more. I'll take you along with that. So what did we learn? Well, there's a bunch of topics I want to discuss. It's like agile, CD development, culture and people. Microservices and CD, business alignment, quality gates and audits, and measurement. So we'll start with agile CD development. Well, I think these quotes were very striking to me. If you wish to be a success in the world, promise everything and deliver nothing. If you look at our results, it's like that. We promised a lot. We said, well, if you give us a bunch of tooling, we can deliver everything. And that's really not what we did. And there's only one step from the sublime to the ridiculous, because I think that's really a small step for us to take. You know, we are almost there. We learned a lot. We did a lot of fun things. But we have to finish up. We have to make a consistent set of it. And how do you do that? Well, there's a maturity model with a different, with quite a different amount of topics. And it says, well, you have a few levels. You have novice, beginner, intermediate, advanced, expert. And we just, like some people said, well, I'm going to get this topic, and he just ran out to this point. But all the other things were still over here. So he was alone ahead of the music, you could say. So you have to do that differently. You have to take a maturity model. This is just an example. You have one from ThoughtWorks with a whole maturity model questionnaire. And you have one from Xavier. It's also very nice. But use one maturity model and then try to make a backlog out of it. Just say, well, we have a first stop. We don't have to be expert immediately. We can first start by being a novice. Then we take a next step and we strive to be an expert. But make those steps because you need them. You can't do it all at once. Just treat your continuous delivery, which is code, of course, just treat it as a software project, because it is. So you have to just have a backlog. You just have to make sure you get your minimum viable products there. You have to prioritize on it. You have to have a product owner. You have to have someone making the decisions. You can't just say, well, we have continuous delivery and it's totally apart from automating other things, because it is automation. And make it a team effort. Enable the team to be green. If it is a software project, it takes time. So you need to make people free to do this. You can't just say, well, do it along with the projects that deliver value. This delivers value for business. It's technical, but it delivers value. It gives you consistency of the landscape. It gives you less risk. So you have to try to sell that to the business side, of course. I think on average you need one full-time equivalent per team to make sure you are able to carry this subject, or you need a separate team. And you have to make sure that the developers and the operations are working together. So you have your DevOps. You have to make sure that you have visibility. So you have to have some tooling to see where you are with your continuous delivery. You have to be green at all times. So you have your tests, and you have to be able to deliver at any moment. So you have to make sure that the teams are going to understand that if they are not able to deliver at a certain moment because their tests aren't running green, they have to fix it as a priority. They can't say, well, I'm changing this nice feature and I'm working on that. No, they have to be green first. Fix your problems. And then you can carry on making all these cool features. And you have to manage your stakeholders. It's not only an IT subject. You have your business, developers, operations, compliance, IT security, accountants. All these people are stakeholders in the continuous delivery process, because they all have their piece of the cake. The question is, who owns the product? Who's the voice of continuous delivery? You have to have someone passionate about a topic. You know, in every software project, you have someone carrying the features. So who is that for continuous delivery? If you make a developer a product owner, that's not really a very good plan, because mostly they aren't the most greatest communicators in the world. And they are less about security, for example, or compliance. They just want to be able to deliver fast, and they are less involved in the risk side of it. If you have a tester, well, it's the other way around, of course. If you have someone from infrastructure, well, maybe they even communicate less than programmers, I don't know. I found that. So it's a hard question. It has to be someone who's technical enough to understand it, and someone who has time, and someone who's passionate about the subject. So sometimes you can find some software architect who was always coding, who's able to bridge the function or something, but you have to search someone who's really suitable for this, and that's a hard task. I can't tell you where to find it. It's somewhere in your organization, of course. I was a product owner myself for a long time for this subject. The CTO was a product owner for a long time for this subject. It was hard to find someone else. Well, culture and people. How ready are we for continuous delivery? Well, if you look at the average graph, you will find that culture is least ready for continuous delivery. The technology is ready to go there for the greatest part of it. And the process is not, oh, this is not going well. Okay. The process is not fully ready, but you can fix that. But it's hard to change people. It's dry here. Now it happens again, of course. It's clumsy. There's a lot of stuff to learn. So you have to even learn project management to do things different. That's hard. And you have to do other things on quality assurance. It really changes your job as a quality assurance employee. And how do you get people to learn all these new things? Because on the one hand, people always want to learn a lot of things. But on the other hand, people are also reluctant and really are into doing the same thing all day long. And they really need to be in there. Because if you look at the topic of DevOps, it's about collaboration. It's about a movement, how we are able to better communicate with each other, better work together. That's the way we can actually make improvements. It's not about technology. Continuous delivery is more about collaboration, about working together. So how did we do that? How did we try to make the organization a more of a learning organization? Well, we have our teams, but we formed some guilds that are people who have the same job. So all the testers are united, all the programmers are united, the architects are united, and they can, in between teams, discuss topics that are of interest, and that will enable you to be more of a learning organization. We also had hackathons, which were very cool. We just said, well, here's a subject, and someone had to prepare the subject a little bit, and then you just get into a room together and you say, well, we're going to get the hang of this. We're going to understand this by the end of the session, and that worked quite well. People had to invent by themselves a lot about the subject, but the time you invest in this, you just lose one day. If you do this every month, you learn a bunch of new stuff. People find it cool. So you can just do this. It really is money for the investment. It really pays you back. And we had knowledge events where people had prepared a presentation like this presentation. And they were people from the department that was delivering software, that was developing software, and they could prepare a topic. Sometimes it was about the things we were actually doing at that point, but sometimes it was about something he thought we should be doing, something we should be learning. So you give the voice to the people, and you can say, well, just take us along in the subject, and you can. It makes people more interested in new subjects. So they look into new things because they think, hey, they're really hearing me when I want something new. And it's not necessarily that we are going to use it, but you had your platform, you had your opportunity to sell it to the audience. And that's cool. So that's just things you can easily do. You don't have to have a big theoretical thing about it. You can just get your hackathons, get your knowledge events, and it changes culture, in my opinion. Well, we have microservices and continuous delivery. That was a whole new subject. If you look at continuous delivery, without the microservices element, well, it was hard but doable. You can just get your build on commit, you can automate the process, you can get your versioning in place and everything. You can integrate directly with the latest version and have your peer reviews, your diversity of test stages. for me that was easy because we had a greenfield project, so we could start over also with the test architecture, of course. If you come from a legacy project, it's much harder because you have to make big investments to get your unit tests in place. But for us, that was something we could build up from scratch, and that was good. So we made all these test phases, we made peer reviews, and we got our process automated. And with that in place, we were able to have our continuous delivery. But then the whole thing got harder because of the microservices architecture. What we had was we had a trigger with Jira. If you have a work item and it was put from test to acceptance, it triggered the release automatically. So every time something was ready to accept, it got a release candidate, it ran all the tests, and then the product owner could accept it. And if it was good, it was shipped and it was put into done. So it was put into production. That was cool. And you have to fix the build directly if you want to do this. So if something gets red, if some test gets broken, if the build gets broken, it's a priority to fix it. I told you that just a moment ago. I'll swap by this. But then we had two problems with microservices. One was the feature shipping. If you test with the latest version, every time you make a commit, you're testing this new landscape with this latest version, but all these other commits that were done, that's where you run the integration test on. So you're testing with a landscape that's like feasible to go into production. But sometimes some features get rejected. And you didn't test the landscape of the one feature you are going to ship in combination with the other feature that isn't going to ship because it's rejected. So it's hard to test all the combinations. And it's hard to be able to choose the moment that you are going to ship it. So if you say, well, we're going to verify, build, accept, and deliver immediately, that's doable because you can just check everything. Every time you commit, you check if the landscape, the full landscape is still green, and if it is, you can deliver. But it's harder when you say, well, I commit, I check if the landscape is still green, but I want to wait. I want to keep it there, and I want some product owner to say, well, now I want to use it. This is a good time because it's the right season or some marketing thing. We have our commercial ready or something. But we want to wait. And at the same time, all these other commits are being put out there. So how do you test the landscape with this thing there in isolation, in quarantine, and then still be able to ship this? That's a problem we didn't really solve yet. It's out there. What we can do is deliver immediately, but if we want to deliver it later, that's a problem. So right now we are using feature toggles, and we are using some smart backdoors, because if we change something at the back end and it isn't used yet, we can ship it immediately, and then it doesn't do anything unless we place a button where you can really use the function or something. So we have some smart ways around it, but the real answer, that's really, to my satisfaction, that answer isn't really found yet. So that's really what you want. You want to ship everything until your user acceptance, and then wait for it until someone says, I want to deliver it now. And the microservices platform just got it more harder, because what are microservices? Just a little wrap up. Microservices have a domain-driven design, have a singular responsibility, well-published interface with an API. They can independently deploy, update, replace, and scale, and they have lightweight communication. Microservices. And we are like in a checkmate position, because we have now more than 100 microservices. We are still counting. And if you say, well, every time a microservices gets a commit, and and we test, and we want to check it with all the other combinations that are out there. So every microservices, for instance, has one commit. Then there are 2 versions of each microservice. And there are 100 microservices, then it has 2 to the power of 100 combinations that should be tested. That's like the checkmate board with all the rice. It gets so big, and your tests run like 2 hours. And I think we would be ready in like 2 billion years or something with testing of one day. So we can't test all the combinations. It's impossible. What we do want is feature shipping. We do want to choose when to ship a new feature. So what do? We can say, well, we are delivering to not really the production, but a production-like environment. And there we just put it out there. We say, well, it's in production, but it's a pre-production phase. And everything that's accepted gets stalled there. And from there we can say, well, now we're wrapping it up. Now we're actually placing it in production. That's a model that could be working. We tried this for a time. So you get like this thing where an application is delivered, but only in a rehearsal production. And then at a certain point we say, wrap it up and deliver it for real. That's not really continuous delivery. You get these hidden silos, and you don't really get feedback at that point. You only get feedback from the rehearsal production environment, where there are no actual users using it. There are just people who are actual user-like. It's like a big fake environment. So this wasn't really the answer to it. I see a lot of documentation that goes this way, where you say, well, you have this union environment, but then you have to do this process multiple times a day to have something like continuous delivery. And then you get the same problem. You can't choose when to ship it. So it doesn't answer your questions. So what do we do now? We say, well, we deliver instantly when it's possible. A lot of features can be delivered instantly. So in our experience, we can make a big problem out of it, but most features can be delivered instantly. The product owner just wants them as fast as possible. Some features have to wait for a certain commercial action or something. And then we build in a feature toggle or a feature branch. And we say, well, if we have some feature where we're not certain about, where we think, well, it's a big risk of being rejected, it's a little bit early to deliver it, then we say, well, we test the combination with the old version of it and with the new version of it with the full landscape. So we have some cherry picking on feasible combinations. And we say, well, it's a team responsibility. If you have a feature that's risky, you have to make sure the integration test runs with the old and the new combination with the full landscape. And with that in place, we are able to manage to go to production every day. So that's fine enough for now. Business alignment is a whole new subject. Is business ready? Is this readable for you? I don't know. Mostly business isn't ready yet. Continuous delivery asks a total different mindset for them. And in IT, we are busy with this. In conferences, there are talks about it, and everybody is pondering about it. But business, this isn't the subject for them. They didn't know they have the choice to deliver more often. Maybe they wanted it, but they didn't think about it. But it also changes their world. And how it changes their world, they are used to having fallback plans. So if they have a deployment, they're used to it being so risky that they have a plan how to go back if it goes wrong. And they actually asked me to have plans for every day. We deploy every day or multiple times a day. And they want fallback plans for that. So we're more making fallback plans than delivering. We can't do that every day. And they still want their manual user acceptance testing. And that's a time-intensive process. They want to check everything in the application, but they have to do that every day for just small changes. They want their instructions. They have system instructions and user instructions. They want to have courses for people. They want to have documentation. They want the communication. So they want to tell people, well, this is everything that changed. And if you have to do this as a process every day, then the IT is fully automated. But the user instruction side is not automated. It's still manual. And that's really something that's slowing you down if you don't do anything about it. So you have to start early by taking them on board and tell them what the plan is. And also try to let them see how it changes their world. That you don't have to have user instruction if you make only these little small changes. You don't have to tell them what's changed. They will just find out. They're mostly, if you do it in a user-friendly way, they're mostly just intuitive changes and they can understand them without instruction, without documentation and without communication. And you have to automate many of the user acceptance tests. And that's also a harsh task. If you want to speed up delivery, you have to make sure you gain trust. Just start by making some small changes, put them out there, and prove that you can do that in a good way. And you have to get your product owner on board. As I said, he has to automate a user acceptance test. Make sure you design them together with the product owner. Say, well, if you would be manually testing right now, what would you test? And then he says a bunch of things, and you just show him that you put all those tests out there. So he doesn't have to check all these things. He can see that you are testing this and that it's green. And he can also approve their tests. So if you make sure that he is the one who says, yeah, if you test these things, I don't have to test anything, you can just go to production. If he is willing to say yeah to that, then you can really speed up delivery because you get the manual user acceptance testing out of it. You can just check some things, but it's lightweighted. And you can also use feature toggling to make sure that the business is more willing to accept, because you can say, well, it's a toggle, I can put it on, and you can use the function, but if it doesn't work right, you can just put it out, and then we have no problem. So there are ways to do that. And you can start by proving your value proposition. So start with some quick wins. Make sure they see how valuable it is to go to production fast and how fun it is to use something that you've just specified last week. They get positive feedback from other users. And give them fast and safe and reliable releases. And screw up on traditional releases, we can do that. So that's a good way to prove we have to do these things differently. And it sounds funny, but it really works. Because every time you release traditionally, you can just say, well, it was caused by these manual steps. And those manual steps have to be distinct. So it's a good time to also let them know it has value to invest in continuous delivery. Then your quality gates. You're nothing in continuous delivery without your quality gates. So you have to make sure you get a good architecture. You can't just say to testers who were used to doing a lot of things manually and some things automated, but they aren't programmers. And now they have to be able to make the whole process automated. That's a hard task for someone with little experience on this subject. So make sure you have something like an architect or programmer assisting your testers with this process, because they are more experienced in making your test code well designed, well architected. And that doesn't go on its own. You have to prioritize your tests, make sure you do the tests that are highly valuable first, and then, for instance, performance and load and security tests, you can invest in making those fully automated later, because mostly security tests are already running in production, so you'll find out fast enough. Your load and performance tests, you can do them, for instance, monthly, and they were already there monthly. You don't really have to be sure that performance keeps being up for every feature you put out there. So make sure you first have your user acceptance testing and your integration testing in place. They are way more valuable. So also make sure that these tests are on your backlog and are prioritized. As I said, you have to check with your product owner the test set you're putting out there. Make sure that it does what it really should do. And monitor your unit test coverage, your code coverage. programmers are really not about making unit tests. It's not fun. Making features is much more fun. But I found that if you really push them to make unit tests, and if you have your code coverage statistics and ask people to do this, you have to do that repeatedly, but it will come out there eventually. People will make the unit tests, but you have to monitor it every day because it's just not fun. And don't forget, testing is code, so you have to have someone checking the structure of the code. For the time, I will go past this one. So what QA tooling did we use? We used JUnit for our unit tests, Serenity for reporting on our unit tests. We used JBehave for scenario integration and API testing. We used Selenium for our UI testing. We used Upsource for peer reviews and the audit track on our peer reviews. So we want to be able to prove later that we did peer reviews to our auditors. And to prove that, Upsource is quite a nice tool. We use Sonar for user coverage statistics, amongst others, and check style. We have been using SOAP UI and Fitness, but they weren't suitable for us. Fitness was complex for testers to use, and in our opinion, too complex. They just got messy. And SOAP UI had a low maintainability. It was a lot of work to each time make sure it still was up to date. And for the architecture, you have to try to get the right testing pyramid. So you want a little manual testing. So try to get business away from manual testing, as I said, to take your product owner aboard. Then you have to have some UI tests, because they take a lot of time to run, and they will slow down delivery, because UI tests are, with us, they're already running for like 2 hours, while unit tests are only 10 minutes. So these tests take a lot of time to run, and if the test set is big, it will take too much time. It will slow you down. You can't deliver 6 times a day if your tests run for 4 hours. And your integration tests are there in the middle. You should have enough of that, but not too much. And this is something you don't want. It's the ice cone architecture, where you have a lot of manual testing, a lot of UI testing. It just takes you too long. It will slow down on your delivery. And for auditors, it was also a nice subject that came on the table yesterday, so I put it in here. Auditors are used to auditing the code base. And if they keep doing that when you are delivering every day, then that doesn't work, because they can't come by every day to check your code. So they have to make a shift, and you have to take the auditors along with that. What they are doing now, what our auditors are doing, are they audit the test set. So they say if everything is green, and if the test set is approved by a product owner, then the audit is being approved. And they audit on the process. So they see, is the process of delivery completely followed? And if we can prove that the process was completely followed as designed, so we had our peer reviews, we have to prove that. We had our integration tests, we have to prove that. So we have to measure a lot of things, and we have to make sure we save those results. And if we do that, then the auditors are satisfied. So we have to make sure for those tests, the process, and prove that it runs well, so your measurements. So this is the last subject. Measurement is important to, amongst others, prove to auditors that you did the right thing. It's important, so that was like information on the CD process. You can see what the health of your landscape is. You can see how many errors there are on components, apps, workers. You can see how much infra components are used, how much they are, where they are going to get into an error stage or something. So you need to have these metrics to be sure to continuously deliver your features, because you can deliver a feature that's infra extensive, and then you have to be able to respond to it very quickly. What we used was the ELK stack, and this one, I can't tell you a lot from my experience. We just used this one. What I can tell you is it works really fine. It's one of the few subjects where we just tried one thing and it worked so well that we didn't even strive to use another one because it was just lightweighted, it was easy. We tried it, we downloaded all the software, and we had it working in one day. And it does everything we want. Everybody is content about it. So from that experience, I can advise you to at least try if it's suitable for you. So it's Elasticsearch, it's Logstash and Kibana working together. It's called the Elk stack. And the architecture is that for time is up. I have to wrap it up. I'll go quickly about it. It has some nice graphical elements where you can see what the health is on your components. And those graphical elements will help you to respond quickly when something gets wrong. Make sure you choose what information to log, because if you log everything, it's just too much. Make it also a team effort. And make sure you have some graphs, some valuable metrics that are... mostly programmers can tell you what metrics to use, so get them on board and let them tell you what things to log. So, wrap up. CD is an agile software project. Make sure you have your backlog, your prioritization. It's not about technology only, it's also about people. So keep that in mind. You have to take your people along. You can't just get it fully about tools or something. It involves IT and business. I see it going wrong a lot. Mostly people in IT are busy with this and business doesn't know anything about it. But they have to be on board because it changes their world completely. And you have to be able to prioritize and deliver consistent sets using some maturity matrix. If you just Google this, you find a lot of them. So this is it. Thank you.